Concludiamo con l'ultima presentazione di Jacob Hensen. Jacob Hensen è attivo nel settore della gioielleria dall'età di 16 anni, ha iniziato la sua carriera specializzandosi sulla galvanica e sulla finitura e attualmente è Business Development Manager per la linea Plating di Legor Group e ci presenterà la memoria intitolata Migliorare la resistenza all'abrasione e alla corrosione delle finiture nere nel settore decorativo. Il presente documento descrive un innovativo deposito nero a base di oro a spessore che è utilizzato come substrato delle più note placcature al rodio o al rutenio nero, ha dato prova di estrema resistenza durante i test di usura e in camera climatica. Grazie a questa soluzione, anche se lo strato esterno si consuma, l'estetica degli oggetti trattati non risulta compromessa.
Okay, so today we're going to talk about wear and tear, improving wear and tear to surface finishing. We chose a black finish, but really we can consider this in any type of way. The reason, and people always ask me the reason why we decided to invest on improving a black finish. And the reason why is it's simple as black and white. And when I say simple as black and white, I'm not speaking about Juventus. I'm speaking about when you have a black surface, and in our industry, it's always over a white surface. If you have a scratch or any defect, it's very, very evident for even the final buyer to see. You can have white gold, silver. Even if you're manufacturing brass, you have palladium or even white bronze over that, and then you're putting the black layer over that. So wherever the scratch is, it's very, very evident. The next reason we decided to do this is because REACH compliance. And this is basically awareness. There's legislative awareness. Every year we're getting another list of black oxidizing agents we could use in the past, we can no longer use. Previously, we could use nickel, and with the NI 1811 laws, we can no longer use nickel in our plating. So we're always trying to find a way to be able to move forward and find something innovative to advance beyond this step. Brand. Every year, more and more every year, brands are coming to our company and they're requesting us to sign a contract saying that none of these chemicals or none of these metals are going to be inside anything that we're going to sell to them. So the brands are also aware, and buyers are definitely also aware. The other day I was at my son's school, and there was two mothers speaking, and one mother was talking to the other mother, and she said, I see a couple of dots on your cheek, you know? And she said, I had that same problem, and it was coming from nickel. So now I don't wear any more jewelry. This could be a problem. This is a problem for the jewelry industry, but the point that I want to make is buyers are aware also. So with these three awareness, then the REACH compliant black processes that we have rhodium and we have ruthenium. These are really the only two that we're utilizing. Rhodium is really easy to use. Ruthenium, we can control the blackness down to about an L38 or 36. The weaknesses of these two metals, we're only able to plate 0.2 micron. So that's really not so thick. It's a flash in the end. So just to recap the why. The contrast of black and white. REACH awareness from the legislative side, from the brand side, and from the buyer side. And black rhodium and ruthenium have a lot of issues in terms of abrasion resistance. Another issue they have is when you apply an oxidizing agent to black rhodium or ruthenium, they actually become weaker and more soft. So in terms of decorative black finishing, there's all kinds of different decorative black finishing. There's anodizing, but anodizing is used specifically for aluminum, so it has its limitations. Anodizing also doesn't have too many color options to go from. If you consider anodizing is used a lot on mobile phones, on television screens, it's used really industrially. Then you have PVD. PVD is extremely, extremely durable. It's used principally in the watch sector, from what I've seen until today, because it has a hard time getting on complex shapes. For example, in the watch sector, you have bands, straps, and really, really easy shapes to sputter onto. But in the jewelry industry, we have a little bit more complex designs. Then you have paint. Paint is really easy to make black, and you have e-coating, you have spray paint. There's many different kinds of paint. But the problem with paint is a lot of brands do not want to put paint on their jewelry, for sure. And then where I go to is electroplating. So electroplating, you can break down into two different types of qualities. Quality 1 and quality 2. Quality 2 that I've seen around would be utilizing black chrome, black cobalt, nickel tin, and these are still being used on chains and things like that in places that I've seen. Quality 1 utilizes more your rhodium and ruthenium. And this is the market sector that we'd like to improve. So our target for improvement was, it had to be black. We wanted to improve abrasion resistance, and we wanted to maintain good hardness. We opened the range of reachable thickness, as that is our principal limitation, 0.2 micron. We wanted to omit the use of nickel and cobalt for the reasons that I said before. And finally, omit the use of copper, because copper is, in a sense, always a source of oxidization. For the nickel-free black gold electrolyte that we studied, we made it with 3 metals, so it's a tri-metal electrolyte: gold, palladium, and iron. So we set this at a pH that was similar to palladium because we knew it would receive all the 3 metals well. And we actually had a target. We wanted to place it as a substitute as palladium, so we kept it with the same physical characteristics as palladium. In the end, the electrolyte that we obtained had a range of 1 to 3 grams a liter of gold, 0.5 to 1.5 grams a liter of palladium, and about 0.5 gram of iron. It works at ambient temperature, and the current density is the same as most baths at 1 ampere per decimeter square. So the actual deposit, you can see the color of it there. The actual deposit is 49% palladium, 39% gold, and 12% iron by weight. That's about 12.5 carats. When we looked at the color coordinates and look at the L value is a scale with 100 being the whitest and 0 being the blackest. The L value was 58, so it was very similar to black rhodium or gunmetal black ruthenium. And the thickness that we were able to obtain was about 2 micron. Now, the chemical observations that we made, that we found were a little bit unexpected. Every 2 days, we noticed that the pH would drop by 0.2. Now, rhodium and other types of things used on the market, like gold, they're very, very stable. But this one, we had a big problem. So what does it mean? It means that the chemical would have to be monitored very frequently to be able to use. There's also some other baths on the market like this, like a gold sulfite bath. So when we went to go testing, we chose a jewelry market plating sequence. So we chose 925 silver plus 0.3 palladium plus 0.2 black rhodium. Then, and this was going to be used as our standard because a lot of factories are using this method for plating. Then to try the black gold, we decided to replace it with the palladium. the first thing that we found is there was extreme color variation. Just by changing the base layer, the L dropped from, with the same black rhodium, dropped from L58 to L54. And this we thought was an advantage because all the customers that we talked to are always looking for a blacker color. Then we tried to place it in the fashion accessory market. And the fashion accessory plating cycle works like this. It's usually over a brass alloy. You have alkaline copper for adhesion, 15 to 20 micron of acid copper for brightness, 2 micron of white bronze, and this gives it hardness. Then you have palladium for oxidation resistance, and finally, black ruthenium. We followed the exact same sequence, and we put the black gold right in where the palladium would be, and we used the same exact black ruthenium. Then we wanted to test it as a final layer. So we used the brass alloy, same sequence, and we put the black gold as a final layer because we wanted to test the oxidation resistance compared to ruthenium. So the normative testings that we used was abrasion resistance, synthetic sweat, and salt spray. There's a lot of different tests in the finishing industry that you can use. There's tons and tons of tests that you can use. But these are the 3 we focus on mainly. They kind of cover all the bases. So for abrasion resistance, we use a test that's coming from the fashion sector, okay? And this, when I mean fashion sector, I mean like leather goods, so belts, handbags, and metallic components like that. And we call it the Turbulent test. And basically, it's just like ceramic. You put ceramic media in this little bucket here, and it's in this shape to be really aggressive. You use about it weighs about 41 grams per 100 pieces, and it turns at 72 RPM, so it's really quite fast, and it just beats it up. Now, the time that you set really depends on what you're going to apply the test to. In the fashion sector, it's fixed at 30 minutes. It must be fixed at 30 minutes. In the jewelry sector, a lot of the finishes that we use in the jewelry sector would not survive 30 minutes. So we apply 3 minutes, 5 minutes, 10 minutes, and play around with it like that. So the jewelry sequence results that we received, that we looked at, you can see the top row was is the standard that everybody's actually using today, using palladium as the middle layer. And this test we only did for 3 minutes. And you can see that the same black rhodium came off much faster than here. So the original idea was to just make 2 black layers, so we had more black thickness. But in the end, we saw that also the black rhodium had better bonding power to the black gold electrolyte. So that was pretty cool. Then we look at the fashion accessory sequence results. We put this one in for 45 minutes just to really take it to the max. So here you see palladium as an underlayer is completely removed, and on the left you see black gold as an underlayer. It still remains black. Is this a pass test or is this a failed test? This is not up for us to decide. This is only up for the brand to decide or whoever's going to evaluate the test to decide. But I would just like to report the results. We also did a synthetic sweat resistance test. Now, we follow a French normative that has a cycle time of 24 hours. The synthetic sweat test, there's several variations, but there's the one that you're in a humid environment or actually the raindrops of sweat down. This one is a direct contact test, so it's a little bit more aggressive. So what you do, you put the synthetic sweat solution on the felt. You put it in the chamber and keep it at a constant temperature for 24 hours. And right here is just an example of a failed result. So after the synthetic sweat test, we also saw that if you use palladium as an underlayer with synthetic sweat and black rhodium over that, there was many corrosion problems, whereas when we used black gold as an underlayer, there was a little bit, but substantially less. Now for salt spray resistance, we follow ISO 92274 for 96 hours. And basically in this situation, the parts are just put in this chamber that you see there, and they're continuously sprayed with a neutral salt spray for 96 hours. When they come out, they have a lot of salt stuck in all over them, and then you have to rinse, and after you rinse, if they look like this is a KO result, a failed result. And this was in our study, you know, we didn't arrive to the good result right away. We had a lot of trials before, so this was also one of our failed results. But as soon as we got the final electrolyte down and we looked at the salt spray results over both ruthenium and black gold, we found that they're exactly the same. What does it mean? It doesn't really mean anything because right now ruthenium passed the test, black gold passed the test, but we know that black gold has a good resistance to salt spray. So just the nickel-free black gold final observations. The black gold alloy improved qualitative results when used as an intermediate layer. And we really liked the results mainly over silver. We liked it better over silver than we did over brass. The salt spray test was at par to ruthenium, but that really means nothing because if you look at the cost of gold and palladium and the cost of ruthenium, this alloy is probably not going to be for a final finish because you're looking at 5 euros a gram compared to 50 euros a gram. The cost would be 10 times more. So we're looking for something else. And also the fluctuating pH. The fluctuating pH is a little bit of a problem, only for the fact that not a lot of people are going to be able to manage this bath in beaker plating. So unless you're going to be able to check it every single day. But I want to conclude like this. From the research, we really found that we found something that we can take to the next level in terms of industrialization. It's Legor's goal to industrialize this, I think, within the first quarter of this year. We'll continue to test this, and we want to match it with like other technologies such as PVD and paint, and also continue to research. Because, and we're always going to continue to try to study different baths that are going to increase the durability of objects. Because in the end, customer goods with longer longevity increase customer satisfaction, brand reputation, and it really, the ecosystem is much better off if we're not just throwing away goods all the time. But the main thing I wanted to get across today is I wanted to conclude through my experience. As working through Legor, I've had the opportunity to travel around the world and see thousands of plating rooms. And everywhere I go, I always get the same question. And the question is, how many days or how many months is my plating going to last? Now for me, that's like asking me, how long is the gas in my car gonna last next week? I think it's really hard to determine that. But the fact is, I don't think that we're applying enough tests as an industry. Because if I look at all the other industries, all the other competitive industries that I've had a chance to work with as Legor, whether it be automotive, aerospace, fashion on the buttons, all of them have a standardized method where the chemical producer, the manufacturer, and the brand are all in alignment on what the target is. And in our case, we're trying to figure out in how many days. So I would like to put a challenge also to the jewelry industry because it's the industry that raised me up and it's the industry where I have the most experience in. I think that we would be better off and we could move better together in the future if we're able to standardize these things. Also, I want to make one more consideration, and my consideration is a story. When I was walking around these big factories in Asia. You go to a big factory in Asia, and it's like 3 stories high, and there's millions and millions of dollars of an investment there, right? So they have 10 or 15 induction casting machines, 3D printing machines, and you're walking around, and it's really, really impressive. And then you follow the owner, and he's taking you back to the back room, and you're gonna find out where you're gonna go plating. And then you get to the back room, and he gives you the beaker. The beaker sets it there, and we got a plate and a beaker. The beaker for me is only a representation, but because for me, I would like to see this industry, the jewelry industry, look at surface finishing and stop thinking inside the beaker, because the beaker is giving us, I think, a lot of limitations. There's several processes that we cannot utilize in the beaker that can actually give us qualitative and even financial benefits. And I don't think that the jewelry industry is able to take advantage of this right now, only because of this. And I just really would like to share this experience with you guys, because I think it's really valuable. I think it's a direction. I think we can move in a better direction in the way that we applicate things. And finally, I wanted to share a little thing with you guys. This is a quote. This is my quote. And it's, if truth is knowledge and wisdom is the application of knowledge, then wisdom is actually the application of truth. I leave you with that, and thank you very much for your time.